Read code question number 289, Game of Life. This is medium question. Let's get into it. According to the Wikipedia article, the game of life, as known simply as life, is a cellular automaton devised by a British mathematician, John Horton Covey, in 1970. Given a board with n by n cells, each cell has an initial state. Life is 1 and death is 0. Each cell interacts with its 8 neighbors, horizontal, vertical, diagonal, using a following 4 rule taken from above Wikipedia article. First, any living cell with fewer than 2, that means 0 or 1, live neighbors die, as if causes on the population. And the second, any live cell with 2 or 3 with neighbor lives on the next generation. 3. Any live cell with more than 3, such as 4, 5, and more, as if by overpopulation. 4. Any dead cell with exactly 3 live neighbor become more live cell, as if by reproduction. Write a function to compute the next state after one update, and a board given its current state. The next state is created by applying above rules simultaneously to every cell in a current state, where births and deaths occur simultaneously. Okay, let's check with example. Input is 1. First, we need to traverse the matrix. This is the start. Start is, in this case, how many the live neighbor. This is only 1, so it will dead. And then now here, and then there are only 1, it also dead. And then this one, it has only 2, also dead. In this case, there are 3, so it will be live. And then this one, it has 1, 2, 3, 4, 5 dead, by overpopulation. And then in this case, 3 live. And then in this case, there are only 1 dead, will be dead. And then this one is the 3, will be survive. And then this one is 1, 2. 1, 2, 2 live cell with 2 neighbor will survive. And then this time you have 2 dead, this one is 3 alive, reproduction, and then this one also dead. Okay, let's check the follow-up. Could you solve it in place? So that means that we do not use extra data structure. How are we gonna do? If we use the extra matrix, and then we can use it to implement. So the reason is, okay, I will show you. This case is okay, but if somehow, okay, let's say this one is 1, 1. In this case, it will be reproduction, so it update 1, 1. Then when we checking this one is updated, so this one also has the 4, so it will die. But actually, it cannot be dead because this one must be 0. So 1, 2, 3, so this one is live. Does it make sense? So the problem is this one. When you scan the matrix, we needed to update before move to next cell. But it is impossible. How are we gonna solve it? Okay, I will show you the after brainstorming. First, let's summarize the 4. In this case, we can summarize to 2. First is live cell with 2, 3 neighbors will be survive, will be lived. And then 2 dead cell with 3 first will be reproduction. And then now currently it has the two digit. That means 0 is dead and then 1 is live. Problem if we change this one, update this one, it will influence the next decision making of the cell to live or die. So in this case, this one is the we able to explain the to bit 0 or 1, but now we have more status. Two more status is the 3 is currently dead but will be reproduction. Oh, sorry. This is 0. 0 is dead, 1 is live, and then this is 2. And then one more is 3. Currently live and then will be lived. And then this one with currently dead and then will be dead. And then this one currently live and then will be dead. So if we change this one, that means when you checking this one, after this will be live and then we updated this one is 2. Then later when we checking, we meet the 2, we just divide by 2. The rest is reminder, just calculate the remainder of 2. So remainder of 2 is 0, and also same as that. So we're able to distinguish. This one also same. And then after finish that, sum of value is 0, sum of 1, sum of 2, sum of 3. In this time, 1, 2 will be changed to that, and then 2, 3. 2, 3 means divide by 2. That is the 1 will be survive. That will 0, that will dead. Does this make sense? Awesome. Okay. Then let's implement code first. I will calculate m and n. M is length board, and n is length board 1, and this one is number of rows, and this one is number of columns. For let's scan the matrix. For O in range n, for m in range n, and then let's check the neighbor. Okay, for neighbor row and neighbor column, we will get from neighbors, and then let's make neighbors. Okay. Neighbors is the array has the tuple is the relative location from the set. So first is -1, -1. Second is -1, 0. And first is -1, 1. And then next 0, -1. And then next is 0, 1. And last is 1, -1. And 1, 0 and 1, 1. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then I will change the relative location to absolute. So n row plus row and column plus column. And then let's check the neighbor. We needed to check the two conditions. First is neighbor position is in boundary of the matrix, and then second is its value is 1. So we needed to count the live. So live is checking the outside of the neighbor loop. So count is 0, and then Okay, let's check the live cell, neighbor live cell. For if 0 and now is the bigger than 0 and then smaller than n, and column also bigger than 0 and then smaller than n, and both and log and column must be, if that is right, and then I will increase counter, and then after finish it, I will check this condition. First the live cell. If the live cell with the 2 and 3 neighbor will be live light, and then second is that cell count is 3 with the 3 live neighbor will be survive. So both log and column plus 2. And then I will iteration one more time to clean the 1. So in this time 0, 1 going to that, and then 2, 3 going to live. So both log and column I just right shift. That means this one is 1, 0, and then this one is 1, 1. Left right shift, and then it turn into 1, right? And then it turn into 0. Does it make sense? Does this make sense? Yeah. Awesome. I think that I finished. Let's check the code. Fix the typo. Oh, it did not. Okay. Oops. Okay, I check the code. Neighbor 0, 1 minus 0, 1 plus 0, 1 is okay. M is both, and allow mn, allow column, count from here, and now in column neighbors, and now in column allow column, and now is m, and column is m. Both and now and column is 1, count 1. Then both count is live, and then count it to 3, or both this one is 0, and then count is 3 plus 2. Yeah, nice. Okay. The bug is that this one has the one more tab. Oh, still has issue. Okay. Interesting. Oh, another one. Sorry. This one we must change it. This one is one, right? So let's change it to bit operation is 1. Okay, looks good. Okay, let's check the time complexity. Time complexity is it take the m by n, mn, to travel scan the whole cell in matrix, and then so each cell it take the iteration, but this one is the fixed value only 8, so it did not count. So and then this one also take mn. So time complexity is big O m n, and space complexity is constant because we do not use any data structure. Thank you.